Yes.
Oh, amazing. Let's see. First of all, I think we had one question to Ross, I think. That was very interesting and we had to skip. They were asking, it would be interesting to see how projecting the plan intended path on the floor would work, unless those shop floors are too uncooperative.
Yes.
What do you think?
This is something we thought quite a bit about. It's a system design problem in part. Short throw projectors can be mounted on the robot. You're fighting for package space with everything else, and they're expensive in both power and money. So it's a trade-off. There's research suggesting that it can be a very powerful explicit cue of what the robot's going to do. But even then you need to be careful. If there's an arrow pointing right, does that mean the arrow is going to go, or the robot's going to go right, or that you should go right? So that can create ambiguity. We did experiment with a simpler form of this, which is a blue dot projected on the floor. This is something that forklifts commonly use in our facilities to indicate when they're coming around a blind corner. And we did see that that was effective and that associates appreciated the advance warning.
Okay, thanks. Yeah, I'm not sure who wrote it, but I hope it's online or here. Then I see that on Slido, on the website, there are already 3 questions / topics, which would be interesting to discuss. Maybe we can start from the most recent one, which is quite general. So maybe and all of you can give your take on this, which says motion safety is still an open issue in real world applications. So what are the holes that should be filled and how should human trajectories be modeled? Assumptions or not? Maybe we can start with Martina.
Okay. Yeah, well, like this is a huge topic, so that I agree that it's still an open topic, and somehow I feel like we often try to go like model free, so we often try to understand like to try to predict the human motion without considering any constraints of the human behavior. But probably like a way to go could also be that we actually take into account that like the human doesn't behave randomly, so that we actually could consider that for trying to generate then safe trajectories. So I will say that maybe if we try to constrain a bit and to assume a bit, we can have like a good real-time performance. So otherwise, like the space can be too large, and then we might have some problems. Yeah.
All right.
So
Tatsuya, what about you? What do you think?
The same topic. So, sorry. Could you repeat?
Yeah. So the question was about motion safety, right? It's still an issue, and how can human, in a way, be accounted for, like the behavior of human?
Yes. So I think that the important thing is that human is not always rational. So irrationality should be considered, I think. So in most cases, in the crash of the autonomous, how can I say, vehicles, it's almost case the human errors. So human errors might cause the unexpected result. So I think we need to consider the how can I say, the bounded rationality of humans is important, I think.
Mm-hmm. I think, Ross, that's related to what you were saying about kind of modeling human robots, not as
there's a lot. There's a lot I could say about safety, some of which I'm allowed to say. We have a whole team that just thinks about safety. It's a huge issue. One concern, I feel like a wet blanket because there's so many things that are cool research ideas, but in practice, maybe not practical. All these really complicated schemes for predicting, you know, machine learning models, what are people going to do? You can't trust that software. You can't trust that it's going to slam on the brakes when somebody's about to collide with a robot. So there has to be a very simple, verifiable low-level system that's going to make sure it's not going to collide with people. And that's how Amazon can have a good safety record. But on top of that, then, that's where there's this opportunity to do prediction and planning to try to anticipate people and work with people. But now this safety system actually, in a way, is like an obstacle that you're trying to avoid, because if the safety system interacts with a static obstacle, it's going to slam on the brakes, false positive, right? And that's very confusing. So it's a hard problem.
Selma, what do you think?
Yeah, the question is also very broad. It really depends also on the context. We've seen a lot of scenarios, so I'm wondering, like, definitely, like, I assume when humans and robots are closely interacting, yeah, it's really hard to say. I meant to say something and then it was said, like, industrial applications, these things are difficult. So I was reminded again how these things are very challenging with humans. If they're not possible to be tracked at all times, if this is some uncertain environment, yeah, I agree with understanding that we have to understand, like, there's a certain level of uncertainty, and bounded rationality was mentioned. And then also there are ideas of how humans generally behave, that they may be very risk averse, especially when dealing with robots, and to account for that as well, probably in modeling human motion and human behavior in general.
All right, so I think let's go to a much narrower and older question, which was all asked 5 hours ago, apparently. But still, you can ask. I think you can answer with one word in a way. Sure, go ahead. So the question is, in a lot of talks, right, the humans are assumed to be able to give high-level cognitive capabilities. Is there something else humans can provide? Ross, go ahead.
I'm not sure I understand the question. Can they provide cognitive capabilities?
No, I mean, that it was assumed that they are able to provide high-level cognitive capabilities. Is there something else human can provide?
Oh, I mean, I think what we're best at are the things that seem easy to us, right? Manipulation is easy for us. Vision is easy for us. These are, subconscious. So I think those, I mean, this is why Mechanical Turk is successful, right? Because people can do vision tasks better than robots. So there's a lot else I think we can provide.
So I'm not sure that this is a answer to the question. So I think that in my research case, the how can I say, nonverbal communication is important for the human-robot collaboration. So in such a case, so not so lower level capabilities for the agent is also play a key role to collaborate with the multiple agents. So I think this point will be important, I think.
Martina.
Yeah. So I mean, first of all, I think it really depends on the application. So if we talk about teleoperation or so, then it makes sense that the human provides just the reasoning capabilities. While if we go to a shared workspace scenario, maybe the things could be different. So we might have that the human could also be an agent itself. So it could also work in the same area and do some other applications. So not only like helping the robot or be helped by the robot, but could also just do some other applications. But that's like, again, it really depends on the scenario that we are considering. And also I will say that there are still some tasks where the robots are not great at, like if we want to manipulate very deformable objects, and so the robots could be not able to do that. So although we don't have to use like very high reasoning capabilities to manipulate textiles, for example, still we have some other capabilities like this very dexterous manipulation that can be very useful in a lot of contexts, not only industrial, but also like domestics and so on. So that's a bit my idea.
All right, so while Selma thinks of this, if you have any question, please, I think you can use a mic, which should be somewhere, and ask the question. So, Selma, what do you think? If a human is not as smart as a hummingbird, can still provide some, yeah.
Yeah, I mean, I guess this means that human is still regarded as a supervisor in this human multi-robot system, but there has been a lot of ideas in the talks of actually having teams, like human is part of the team with multi-robot system, and in this case there would definitely be a lot of physical interaction and very low level tasks being executed in this interactive scenario, like handovers and manipulation in general, definitely, if we consider it now as a human robot team and not just like human and then multi-robot system and supervisory interaction.
Yeah, makes sense. Questions from the audience or hints? Jen, please. Oh.
Thanks very much. So there were a lot of points about situational awareness and how robots can provide situational awareness for human operators. But if we're talking about collaboration between the two, I think maybe Ross, you already mentioned this in a lot of your slides about how the robot also needs situational awareness, because if it sees the load that the person is carrying, it can infer where the person is going. So where do you all think the state of the art is in going in the other direction, where the person is providing more information about what they want to do and their intentions, and how that ends up being able to help the robot?
There's a lot of low-hanging fruit there at this point with deep learning that I'd love to try out in terms of gaze recognition and trying to map context in terms of obstacles onto behaviors. So possible research idea there.
Yeah. So I think that so how can I say that? Yeah. So yeah. So for the robot, the higher level, how can I say, the cognitive capabilities is very difficult to understand. So, however, the intuitive direction for the robot is friendly for humans. So I think that this is a very challenging topic, but to collaborate with the friendly with the robot, we need to challenge that kind of difficult task. Yeah, I think.
So I don't know if I understood correctly. So the point is that if like the human has to also understand what the robots are doing, right?
How does the human show intent or provide intent to the robot?
Okay. Then I didn't get it. So, thank you. Yeah, I mean, like this is a super big issue, I would say. And like there are still, so I'm not directly involved in this, but there are still some methodologies, I would say, that try to do that. So that try to understand like the intention, either explicit or implicit. And like, I think that's something fundamental when we want to have like a close collaboration. So we need to understand like how we can do with the humans. So if we have a human-human interaction, we are able kind of understanding that, and somehow we should go like in that direction also for the robots, if we want to have like a really intuitive interaction and so on. But yeah, and also the problem is that when we have multiple robots, this becomes like even more challenging, I would say. So I don't know how to do it, but I agree that's something we should go for.
Maybe Selma wanted to add something.
So the question was how to understand human intent in such human multi-robot scenarios, right? Right? Or
Yeah. Yeah.
Okay. Yeah, I mean, yeah, this is also a really big topic. And of course, many people are working on this. It really depends on also interface that we have. If it's from human or from humans to robots, it depends on the interface that it lies between human and robots. And it would be really, like gaze was mentioned, this is a pretty cool topic, but also like there's a lot of work done on in the haptic sense if necessary, and some people are already working on like actual verbal conveying of this. Yeah, it really depends on the interface and the context as well, but it's really a big topic.
I thought it might be worth acknowledging why this is so hard. I think much harder than the other way, because actions are interpreted in context. And when you change the context, the very same action can mean something totally different. And context is literally the set of the state of the world. And you don't know which pieces of that context actually matter to people in a given situation. So there's a giant conditional Bayesian probability that you'd have to sort out there. That's really the problem.
Perhaps more philosophically then, do you think that it should be the robot's job to interpret the human, or should the human be explicitly giving information to the robot? Which do you think will work better in the end?
In Amazon's context, in the sort center, you can't really put the onus on people because they're just there to do the job. So the robots have to be good enough.
I think that for trustness between the robot and humans, to giving much information increases the trustness. On the other hand, the complexity will also increase. So for humans, the how can I say, appropriate level of complexity is suitable. So it is very difficult problem, but I think that how can I say, humans robot need to reach to the humans for understanding its intention. But yeah, much information might cause the how can I say, the undesirable results. So yeah, appropriate information is I think that reasonable.
Yeah, so I would say actually that probably the middle solution is could be the best and the working one. Like I would say that probably a hybrid solution could work. So it will be amazing if like the robot is able to read our mind and understand everything implicitly. And there are some works that like try to go in this direction, maybe like, I don't know, follow the gaze of the human and so on. But probably like having a fully autonomous system in this sense that can understand everything we want to do implicitly could be super tough. So if we like add just a few explicit interaction, like the overall system could be much more effective and like more feasible, I would say. So I don't know if one day we'll go to a fully implicit one, but at the state of the art, probably we should kind of mix both of them.
I think it will, because and by induction, whatever Asimov said, wrote in his book, is being
Right.
done, and he said that robots will read our minds. So
Okay.
at some point that will happen. Let's see. In the interest of time, I mean, also in the interest of letting people here enjoy Kyoto in the lights still today, maybe we can do our very last question, which also was asked a couple of hours ago. So let's try to give an answer to this. Optimal autonomy can be hard to comprehend by a human in the loop. So how do you think this can be resolved, not increasing training times and thus trust in the HMRS? So this is kind of related to what we were talking now. So maybe if you can add anything on this. So here is talking about not general legibility, but like this optimal autonomy.
So I think the question is about how do you design an optimal human robot system?
Also, should it be optimal
Should
in
it
a way?
be? I
Kind
mean,
of, yeah.
For some objective function, it should be.
It has to be.
You know, maybe within 90% of optimal is good enough. I mean, this is actually a lot of what we've been studying because you can think you know what your user wants. There's a quote from Steve Jobs basically saying, don't trust users to know what they want. So it's important, you know, to ask people what they want, but then prototype, you know, test it and find out if they were right, and watch how it evolves, how it works, and close that loop as tightly as you can. Go through as many cycles as you can of design, redesign. This is basically the agile process is kind of how we think about it in software developing. I think that's how it slowly becomes closer to optimal.
So I think the optimality depends on the objective function. So for example, in accordance with regarding the efficiency, so fully automated system would be optimal. However, this is a society for humans. So in terms of the happiness, I think to consider the well-being of humans will be important. In this sense, the optimal solution would be the mixing the automated and human manual system, I think.
Okay, so I'm actually trying to like find some optimal solutions in human multi-robot systems. So I might not be the perfect person to answer, since I think we should try to go for that.
The 100% optimal.
Yeah, that's undoable. So yeah, of course we can, like as mentioned, like we cannot know exactly what's the best. So we do have some like quantitative metrics that we can try to optimize for. And I still think that it makes sense to consider these metrics. There are also like metrics that can be defined to have a fluent human-robot interaction. So there are also these studies about what actually the human prefers for a human-robot interaction. So we could also optimize for that. But then, of course, the problem is that like this optimization cost is something that we believe that could be useful, but it might not. So maybe we should go also to, again, to an hybrid solution where we also like ask the human, like, are you happy? And we can also like adapt to the plan accordingly. So fully optimal is kind of impossible in my opinion, also because every human is different from another. So there is not, I don't think there is a unique optimum. But we can try to go for this unique and then slightly adapt according to the preferences of each person.
All right. Selma, I think you have the last comment on this panel session.
If it is meant to have optimal human-robot interaction or design optimal solutions, I think this is difficult in my opinion, because humans show over and over that they're not optimal. For many tasks, they behave suboptimally, as mentioned. Like for many tasks, they're risk averse. So already there, you can't design optimal solution for many tasks in this context if they include certain level of risks, and there might be probably many more things to consider. So I think if we would be going to human-centric solution, optimal might be difficult in terms of finding appropriate costs. So it's really, is it focused on the task and task efficiency, then optimalities, I would say desirable, but if it's human-centric, I think it's really difficult to have it optimal.
All right. Thank you very much. It sounds like we don't need human multi-robot systems, just multi-robot systems to keep the optimality. All right, let's give a round of applause to the panelists again.